big welcome to both Dr. Derek Yach and Professor Gerhard Scherer, who are here to discuss the new research paper, which they've authored, which has been published in the Wiley Analytical Science online journal. And this study presents a promising tool to help build the evidence base in tobacco harm reduction. For many years, reduced risk products have been dismissed due to lack of evidence, but Derek and Gerhard are challenging this narrative with a new tool, which is biomarkers. So before we dive into the study, I'd love to hear a short description of you both in terms of your scientific background, your current roles, and why you became interested in this particular topic. So Derek, would you like to go first?
Yeah, real pleasure to be with you all. I'm an epidemiologist, physician epidemiologist, and for decades I have been interested in asking the question, what are the health outcomes and health effects of tobacco and tobacco-related products? And what happens if people quit? How fast do the risks and the outcomes change? We've relied for almost 65 years on a very simple approach to do that, namely, get a bunch of smokers, a bunch of ex-smokers, a bunch of non-smokers, follow them up until they're all dead, and then look at what they died of. And that served Sir Richard Dawell, Sir Richard Peter extremely well through the British doctors' studies and many of the cohort studies. But there's several problems with it, particularly today. First, it takes a long time before you can get definitive answers about cause and effect. Second, it doesn't really allow for change in the way you're using products over the course of many decades. And third, it ignores the fact that today, as opposed to 65 years ago, we have a wide variety of ways in which people can use nicotine. Some are virtually inert, others, when they're in the form of a combustible product, will kill you. So for that reason, we felt it very important to review the progress in being able to assess what you're truly taking in, measuring it through measures in the blood, the saliva, other bodily fluids, to check whether you're truly taking in combustible products, only nicotine, some combination. To do that, it would actually change the way we do our epidemiology and not rely anymore on a simple one-off questionnaire done 65 years ago, or maybe even 10 years ago, but allow us to do more dynamic measurements over time. The second rationale for doing it was to be able to ask the question, can we predict whether the changes that people have, either when they quit completely or they switch to a reduced risk product, be it snus, nicotine pouch, heated tobacco, or an e-cigarette, before waiting for them to die, which is incredibly important. So many people are concerned that we simply don't know the long-term effects of many of these products. Well, as Gerhard, I'm sure, will explain, our biomarkers of outcome are allowing us to get closer to having answers to, will this have an impact on cancer? Will it have an impact on cardiovascular disease or on respiratory disease? The three biggest concerns that we have when we're dealing with tobacco. And so that was why we felt that putting out the incredible progress made by scientists around the world over the last 10, 15 years in the area of biomarkers is something that we now need to take seriously as a public health community, as epidemiologists, and later we'll talk about the benefits to the insurance industry as well.
Thank you, Derek. Gerhard, would you like to provide some thoughts?
Yes, my name is Gerhard Scherer, and I'm a chemist and a biochemist by education, and I have additional education as a toxicologist. And my work in this started in the 80s when I became one of the leaders and managing director of ABF, which is Analytisch-Biologisches Forschungslabor in Munich, Germany. And we started with nicotine measurements and body fluids. And then we started to develop biomarkers of exposure first to get access to the burden from tobacco smoking, which toxicants are taken in by smoking and what are the amounts in the body fluids. And these methods were validated and improved over the time, so that we now, after about 30 or 40 years, we have a panel of biomarkers of exposure and also of biomarkers of biological effects, which are able to monitor the burden of smoking, but also other burdens from the environment, from the workplace, from food, and so on. So this is my background and my interest, biomarkers, development and application since almost 40 years.
Gerhard, sorry to interrupt you. Do you mind speaking closer to the microphone? We can't hear you very well.
Okay.
If that's possible.
Sure.
Thank you for those introductions. In very simple terms, Derek, can you explain what a biomarker is and why is it useful to measure them?
Yeah, so biomarker is short for a biological marker. So it's a means of being able to get a quantitative assessment of whether, in the case of a biomarker of exposure, whether somebody has got some toxic substance that they've taken into their body, or not even a toxic substance, any substance. And it measures the way in which the body metabolizes it, or it turns it into subfractions, and those get measured as biomarkers. So, for example, the classic one in the case of tobacco is nicotine breaks down to cotinine in the body. By measuring cotinine in your blood or your saliva or your urine, you're getting a good measure of whether people took in a certain amount of nicotine. You won't know at that point whether they took it in from a combustible cigarette, from a nicotine replacement therapy, e-cigarette, or nicotine pouch. To do that, you need to then look at what are the biomarkers of the products that are combustible. And so carbon monoxide, the deadly carbon monoxide, we all know can cause deaths during the winter if you don't have your heaters well adjusted in your houses. Well, when you're taking in cigarettes, you're going to increase your level of carbon monoxide. And if you measure carbon monoxide in the blood alongside nicotine, you know that you're probably a combustible cigarette user. If you don't see carbon monoxide, you can be fairly certain that you must be using one of the purer forms of nicotine, the pouch nicotine replacement therapy or e-cigarettes. That's on exposure. So it's a good way of measuring whether people are exposed. Obviously, there are issues around how long it stays in the body and how you interpreted that, which we write about, but I won't go into here. The second type of biomarkers are proxies of the ultimate disease that we're concerned about. So instead of waiting for lung cancer to appear, we know that early on, there are indications in the blood through measures either of proteins that the cancer actually puts out, or RNA or DNA subsections that can be detected through, again, liquid biopsies or blood-related biopsies, or we call them biomarkers. Now, knowing that they are present in the body even before you have the full disease allows people to predict whether you're going to ultimately get it. And we know that from long-term studies. So the biomarkers of outcome are very different. They are measured to be able to predict your likelihood of actually getting cancer, heart disease, and whatever. And while not definitive, they are increasingly giving us a very high degree of predictive power. So you won't have too many false positives and negatives, as some of the newer, particularly the newer liquid biopsies, or even a decent CT scan, or even a chest X-ray would be examples of how you might predict ultimate outcomes.
So I'd like to now dive into this study that you've both authored and has been published. Why did you identify this study as especially relevant to tobacco control? And can you please talk us through the methodology? Could you start, Derek?
Yeah, I think so the two real target groups for this review were epidemiologists carrying out large studies looking at whether tobacco causes death and disease. We're talking about some major studies going on in the world. I mentioned already the large cohort studies that have been carried out from Oxford, the American Cancer Society. Well, we're now on the verge of one of the world's largest studies starting to move ahead, the British Our Future Health study, which will involve eventually 5 million people who will be followed for many decades. And when I started learning about this study, I felt it was time that we didn't rely purely on questionnaires to assess whether people were smoking, particularly because of the very wide range of ways that people are increasingly using nicotine products, and that's likely to increase. So the use of the biomarkers will help the epidemiologists. It'll help them refine what truly are people exposed to without a reliance on what their memory or what their recall tells them about what they did today or yesterday. And then the second reason is to be able to give some sense of what is likely to come in terms of death and disease without waiting 40 to 65 years. I mentioned earlier the insurance industry being interested. So the reality today is that most insurance companies around the world do not adequately distinguish between whether you're a smoker, whether you're using nicotine replacement therapy, or whether you're using nicotine pouch, e-cigarettes, or snus. And the implications of this first for the consumer are that if you're using any type of nicotine, you often get loaded on your insurance as if you're a smoker, which is plainly wrong. And secondly, it doesn't allow for some of the insurers who want to be more science-based to actually have products that even encourage people to move from being a smoker to a non-smoker or reduced risk tobacco user. By having these markers, it'll give them the assurances that they are seeking. And we know this from surveys and interactions I've had over the last 3 or 4 years with them, to actually give new products out there that will rely on biomarkers to assess exposures and outcomes.
Gerhard, would you like to add anything to that?
Yes, I like to state that biomarkers become of interest in the field of tobacco control when we come to tobacco harm reduction. By tobacco harm reduction, we mean that users of hazardous products, especially cigarettes, switch to products which are less hazardous, but supply also nicotine, which most of the users, of the smokers, are interested in. So if users switch to new products, less hazardous products, biomarkers are a very important and useful tool to show first that the exposure, especially to toxicants from tobacco smoke, are reduced by a large amount. The reduction in the new product is more than 90%, and this can be shown by biomarkers of exposure. And as Derek mentioned, the other type of biomarkers which are of interest for tobacco control are the biomarkers of early biological effects. And by applying these types of biomarkers, one can show that the risk implicated with the use of the new products is really reduced, and this can be shown much earlier than waiting for the results of epidemiological studies, which would take decades, usually 2, 3, or even more decades. In addition, I like to mention that 2 properties of biomarkers, especially biomarkers of exposure, are important. One is the time which is covered by a special biomarker, which shows or monitors the time when the product was used. We have short time periods, which are hours to days. For example, carboxyhemoglobin is a short-term biomarker which reflects the behavior, the smoking behavior in the, I would say, the last day or so. The half-life is about 2 to 4 hours of this biomarker. We have medium-term biomarkers which monitor the behavior over, say, the last days up to weeks. And we also have long-term biomarkers of exposure, for example, special hemoglobin adducts, which monitors and reflects the behavior during the last months. This is dependent on the lifetime of the red blood cells, the erythrocytes, which have a lifetime in humans of 120 days. And another important property of biomarkers of exposure is the specificity. Specificity means is the biomarker unique to the product you used, or are there other sources which would also increase the level in the body fluids, but have nothing to do with, for example, using cigarettes or using some of the new products. Of course, nicotine is a very specific biomarker for all nicotine-containing products, but you would not be able to differentiate cigarettes from e-cigarettes, from oral tobacco or anything else. But we have also specific biomarkers which are specific for tobacco smoke, for combustion products, which are formed during the burning, the smoking process. All chemicals which are formed during the smoking process would be specific for smoking and would not be increased in users of e-cigarettes, for example, or heat-not-burn products. So these two properties are very important if we are measuring biomarkers.
Could you also provide any examples where biomarker data have provided useful contributions to inform regulation? Derek, would you like to answer that one?
Yes.
Well, yeah, I think let's just take the field of tobacco and say that that's exactly what has not yet happened, but we certainly hope it does. I think it's a great question, and I would imagine there are examples in the environmental health field where there are toxic chemicals and products which break down in the body into biological markers that then are used for the setting by the EPA of standards that are acceptable. There are many that are used for impurities coming even from the food and food safety areas. So I think they're fairly widespread in use already in the regulatory environment, but not in the tobacco sector. So in food, in pharma, and environment, these have been around for many years, many decades. The frustration has been that we haven't seen them being taken as seriously as they should. And just think about the big surveys we rely on worldwide. We have the Global Youth Tobacco Survey, we have global adult surveys, we have national studies, all of them being carried out in the face of a dramatic change in where the nicotine is coming from in the populations. And none of them are going to be adequately able to distinguish where is this truly coming from. Is it coming from relatively non-toxic, inert nicotine pouches and e-cigarettes on the one hand, or is it coming from continued use of combustible cigarettes? And that's why I feel fairly passionate that it's urgent that regulatory authorities, starting with WHO, even the FDA, many of our academic scientists around the world, stop this over-reliance on an old-fashioned questionnaire approach that is often used to assess your status on using tobacco products once in your life, and then a whole lot of other conclusions are drawn from this, usually incorrectly.
My last question is about consumers, because when we talk about science, we often don't talk about consumers as well. But in terms of biomarker data, do you think that this data would be useful for consumers in allowing people to make informed decisions about switching away from cigarettes to choosing safer products?
Yeah, I'll let Gerhard comment afterwards, but in fact, I felt early on, having worked with a company called Vitality, known well in the UK, South Africa, and around the world, where they focus on the power of measurement to motivate behavior change, that would be incredibly empowering for somebody who's a cigarette smoker to be able to take a little saliva test and see that they're now freed of the impurities caused by combustible cigarettes. And just a simple color switch from red to green, I think would motivate them to switch and motivate them to stay switched and off the combustible product, because they'd see that it's actually having an impact on some biological system in their body. And there's nothing more powerful than seeing these kind of visual cues to actually bring about change. So yes, I do see potential consumer applications in the same way as consumers are now taking to the use of diabetes tools to measure their diabetes status and monitor them, or the use of sensors for our mobility and walking and steps and swimming and so on.
Gerhard, I'd love to hear your thoughts on that as well, if you have any.
I like to add a very short aspect, which is very important, especially in the phase where we have cigarettes on the market, as well as the new generation risk-reduced products. We will have certainly several years, maybe even a decade, where users use at least two or even more than one product. That means in addition to cigarettes, they would use, for example, e-cigarettes. And especially in epidemiological studies, it's very important to define the product use pattern of these people which are investigated in these studies. If we have dual users, that means, for example, cigarettes and e-cigarettes simultaneously, and I suppose that many people are dual users, the reduced risk usually is not very large. We have many epidemiological studies which already show this. And in some studies, the wrong conclusions may be taken. People tell you that they use e-cigarettes, but do not tell you that in addition, they also use conventional cigarettes. And in the end, you see an increased risk, over the level of non-users. And the wrong conclusion would be, okay, e-cigarettes also are implicated with an increase of risk. Therefore, it's very important to have the compliance well investigated and defined in these studies. And biomarkers can help to do that.
And before we end this short webinar, are there any final words you would both like to say?
I just want to echo Gerhard's last comments because they're profoundly important. So biomarkers don't just give a yes/no answer to whether a substance is present. It gives you a sense of the dose and the real exposure. And I think this will certainly help us as well, not just understand dual use better, but also understand what happens when people go from a pack and a half a day to under 5 cigarettes a day. Most of the large studies suggest that when they do, they cut their risks of lung cancer and heart disease by significant amounts, maybe 80% plus. And yet we don't put that data out for smokers to know that if they're struggling and they don't want to use nicotine replacement therapy, they may not want to switch to e-cigarettes or whatever. If they cut down from a pack and a half a day to 5 a day, they're going to have the same potential benefits almost of quitting.
Yeah, I like to mention 2 points. One is that we already have biomarkers, especially biomarkers of exposure, which are well validated, and there is really, it's necessary really that these biomarkers are applied consequentially in suitable studies. I mentioned already epidemiological studies, in many field studies, and especially in so-called post-marketing studies, these biomarkers could be applied. Another point, the second point, would be that the field of biomarkers, and here I mean especially the biomarkers of biological effects, is not yet completed. There's many open questions and many research to be done, especially these biomarkers of effects have to be validated so that they can really give sound and solid information when applied in suitable studies.
Okay, so we'll end our webinar here then. I'd like to say a big thank you to both of you for your time and for showcasing your knowledge on this topic. And thanks a lot to the audience for tuning in today. We're going to release lots of content from today's recording onto our thr.net website and social media platforms. So please check thr.net Twitter and LinkedIn accounts. I'm also going to post the link to the research paper which has been discussed. Thanks again, and great to see you both, and I'll be in touch.